G'day guys, today we're going to be talking about similar triangles. Now, two triangles are similar if one is an enlargement of the other, or they have the same angles, or have the same ratio of sides. Alright, so in this case here, this one here, when you're looking at the diagram, we can see that 40, 40, 80, 80, 60, 60, because they have similar angles, they have to be similar, therefore the sides will be in the same ratio. We're going to use this really technique to actually find unknown sides. Alright, that's really what we're going to be able to do and to solve some triangles. Now, conditions. Alright, so two triangles are similar, the triangles are equiangular, or corresponding sides are in the same ratio. And what you have to do is make sure that you get the right pairs of sides that you're looking at. So a pair of triangles are similar if one of the following is true: the triangles are equiangular, the corresponding sides of the triangle are the same ratio, or two sides of each triangle are the same ratio and the included angle. Alright, so that would be the angle between the two sides. Right, let's get straight into looking at an example. So this one over here, I would say these two triangles are similar because all of the angles are the same. Now, if I rotate this in a different direction, that might look like it's exactly the same, but then what you need to try and do is to rotate it so they do look the same, and then label the angles, and you'll get basically what you're supposed to see there. Now if we come down to looking at over here, so the sort of thing I can do here, if I looked at this side here, let's say I said that side is 5, then the ratio of 10 to 5 is 2, so therefore this side over here have to be 6, and that would have to be 4. Got the idea? If this side over here was, say, 1, let's do it in a different colour. Right, so ratio of 1 is to 10, so this side over here would have to be 1.2, this side over here would have to be 0.8. Right, so the sides are in a particular ratio, right, which is really, really important when we start looking at that. Now, when you start doing these, some triangles will be really easy to actually do, other triangles will be a little bit harder. So the key steps in solving these is to label all the angles that you can do, right? Put the information to a table like the one over there, and then since they have equal angles, they have equal sides, you can start putting the corresponding sides together. And then you can actually solve the equation to work out the unknown. Right, so let's do an example. I've just got one here from the textbook that looks like the sort of thing you do here. So the key step is to, first of all, when you're doing these, you have to prove that the two triangles are similar. Right, so for this particular one, what we've got here is we've got this angle here, which is common to both triangles. Because these are parallel lines, B1 and B2 have to be the same angle. Alpha 1, alpha 2 have to be the same angle, corresponding angles, because they're parallel lines. So therefore they're similar, right? Or due to angles. Right? And then the key thing is small triangle, big, large triangle. That's generally what you're going to have. When we're putting the sides there, X goes into the thing over here. We don't know A to E, or the B angle. We know that this side over here, A to C, is going to be X plus, so it's going to be X plus 2.1, isn't it? When we start looking at that. Alright? So that's what is there, and then we know 5 and 3, the other corresponding sides that we've actually got there in the triangle. Alright, so you have to put that information, will allow you to do that easily. I'll show you two techniques I think that may work for you when we start looking at this. Right, so if I was doing this question here, that's our first example. Let's get me a pen. So what I might do is I might go, that particular angle there is dot. So therefore that would make this other angle over here dot. Alright, so those two angles there are going to be vertically opposite. Alright, so have to be equal. So the dots are vertically opposite. So therefore this means that this angle over here is alpha, therefore this has to be equal to alpha. Alright, so, and we know that alpha is equal to, was it 90, take the dot. Okay, we know that's the case because we know there's 180 degrees in the triangle because it's a right angle triangle, therefore the other side has to be the same. So therefore, similar triangles due to all angles equal. Alright, so now there's two ways of doing this when I start looking at actually trying to work out the corresponding side. Because what we're trying to do here is solve for x. So what I could do is I could draw these two triangles in the same orientation. So then I could label the two sides. Right, and you start by labelling the angle. So that's 90 degrees, that's dot, that's alpha. That's 90 degrees, that's dot, and that's alpha. And so therefore the dot angle over here is 4 meters. This one over here is 12 meters. This side over here is 18. My pen's playing up. So this over here is 18 meters, and this one over here is going to be x, our unknown. Alright, so that's by drawing the two triangles in exact the same orientation. That actually works. The other way to do this is to look at the grid. We've got small triangle, we've got large triangle. This, remember, is just about to help you. We've got the right angle, we've got our dot, and we have our alpha. So if we're looking at that, that's for the big triangle is 18. For the small triangle, that's going to be x. For our dot, that's going to be scratch, scratch. And for our alpha, that's going to be 12 for the bit large one, and it's going to be 4 for the small one. So by doing that, what you're doing is getting it quite clear, the ratio of the sides. So you don't have to do both techniques, but you need to work out a technique that's going to work for you. Now, when you're solving these triangles, the simple thing is to always put your unknown on the top left-hand side. So that means we'll go x, so that's going to be x to 4 if you use a small triangle, and the same ratio is 18 to 12. So therefore, all I need to then do is always bring that up to the top line over here. So that becomes x is equal to 4 times 18, all over 12. I'll cancel that. There's going to be 1 and 3, so therefore that's equal to 6 meters. And I think you can see the ratio there anyway. Alright, so the techniques that you're going to use, first of all, you have to prove it's a similar triangle. Then you need to identify the angles and the sides in the triangles that are corresponding to each other, either by drawing them in the same orientation or using your little table over there. Now, either technique is fine.